Welcome back to another lesson. We're going to be reviewing composition of functions and taking a look at what that means and also kind of getting a taste today for maybe how the AP exam in calculus would ask us about a topic like this. Let's take a look at some basic function notation and just do a quick little review. So in your basic algebra class, you probably saw function notation, and you probably understand that when you see something like f of 2, it just means take that 2 and plug it in for the variable in the problem. So let's try problem A here. So it says find g of 2. Well, that means I'm going to use the g of x equation, and I'm going to take 2 and plug it in. So 2 times 2 plus 1. I'm replacing the variable with 2. And really what this is saying is, what is the function? What happens when you put 2 in for the variable? That's what this function notation is really referring to. So when I evaluate that, I just get 5. So f of negative 1 would mean take negative 1 and put it in for x in the equation. Now, one thing to be careful of is it's real easy, as I've said in previous videos, to make little itty-bitty mistakes. And they're the dummy mistakes that when you realize you've made it, you feel like a dummy because you know better. And one of the dummy mistakes that I see a lot is when you have a negative value, people often forget that when you square a negative, it turns into a positive because you're saying negative 1 times negative 1. And the reason why that mistake happens is because people rely on their calculator. And when they type it into a calculator, they just do 3 times negative 1 squared minus 5. And when you do that, you get negative 8 in this instance, which is not correct. So you always need, if you're going to evaluate in a calculator, to put those parentheses around that negative value, because then this becomes 3 minus 5, and the answer truly is negative 2. So be careful about making those mistakes. Try to avoid them. G of A means take A. What is the function of A in the G equation? It just means take A and put it in for the x. Find f of x plus 1. Now this one is maybe a little bit more complex because we now have not a value or a letter, we have an expression, a function. And what we're going to do is we're going to realize that the f of x equation really means we have 3, and then think of x not as a single letter but as a box or a set of parentheses. So this set of parentheses represents x, because a variable, really you can think of it as a box, or some people call it a bucket, where we can put a value in. The value we're going to put into that bucket now is x plus 1. So we're going to take that bucket and we're going to fill it with x plus 1. So really this is the answer to this equation. Now, I would leave it like this if this was my answer on a test or on the AP exam. This is where I would leave it. However, it's always good to go through the algebra of expanding it, because on a multiple choice test with the AP exam, you might find that they took the time to multiply out the x plus 1. So let's review how we would simplify this. First of all, x plus 1 squared, you would need to write that out twice. That's what it means to square a quantity. When we square a binomial, we need to use the distributive property to evaluate that, to multiply it out. Now, some people learn this with the acronym FOIL. It helps us remember how to distribute the terms properly. First, outside, inside, last. And if that's something you're comfortable with, excellent. I'm going to call this the distributive property because technically that's what it is. So I'm going to distribute x times x is x squared, distribute the x to the 1 plus x plus 1. This turns into x squared plus 2x plus 1. Now I'm going to take that and I'm going to put it back into the function, and I have to distribute the 3 throughout. Minus 5. So now distributing my 3, I get 3x squared plus 6x plus 3 minus 5, which finally multiplies out to 3x squared plus 6x minus 2. Now, this is probably what you would find on a multiple choice test. So if you look and you don't see your initial answer, you may need to do some further simplification. However, on a free response or an open-ended question, don't go through the extra steps, because if you accidentally make a really common mistake where you distribute the exponent through, which is a big no-no, don't do that, that you're opening yourself up to mistakes. And so we want to avoid that if at all possible. Now, g of f of x, we're going to treat this the same way, because just like in part D here, this is an expression. Well, you guys, f of x is just an expression. So if f of x is 3x squared minus 5, and g of x, let's see what it was 2x plus 1, well then g of f of x just means g of 3x squared minus 5. So in the same way, we're going to take that 2 and we're going to take that bucket, and into the bucket, which is x, we're going to plop 3x squared minus 5. Now this one is pretty easy to simplify. 6x squared minus 10 plus 1, that's 6x squared minus 9. So some basic simplification is encouraged. Now g of x, much the same way. So if we're going to evaluate this, remember we're going to have that bucket, and into the bucket we're going to put 2x plus 1. So it simplifies to 4x plus 3. So this is how composition of functions work. And when you're doing f of g of x or g of f of x or something like that, the name for this, the technical term, is called composite functions. And a composite function simply means that you're going to take one function, g of x, and you plug it into another function, f of x. And we have some notation for this. And so f of g of x, which is what we saw in our examples above, is often also written like this, FOG or FOG. I say FOG all the time. But what you need to remember is that whatever comes second, that's what gets plugged in. So if you ever see GOF of x, that just means find g of f of x. You're going to plug the f function into the g function. So let's do a couple of examples with this notation just so we can get used to it. And if you want to pause the video and give these a try on your own, I really encourage that. It's good practice. And then you can hit play and see how they're worked out. So here is the first set of examples here. F of g of x, remember that just means find f of g of x. Well, g of x is x squared. F of x is x plus 3. So I'm just going to say x squared plus 3. Ta-da! There we go. Now g of f of x just means find g of f of x. That means I'm going to take the f equation and plug it in for g. Well, the g equation is the bucket squared, so I'm just going to put x plus 3 and plop it in. And if I needed to multiply that out, I'd write it twice and use that distributive property or FOIL if that's what you're comfortable with. F of g of 4. Now, there's two ways that I could approach this particular question. I could find g of 4. Because remember, this just means f of g of 4. I have the g of x equation up here. G of 4 is just 4 squared. So really, this is asking me to find f of 16. Well, f of 16 is just 16 plus 3, or 19. So there's one way that I could go about it. The second way that I could go about it is I could realize that I actually have an equation for f of g of x. FOG of x was found in part A, and it's x squared plus 3. So I could use that and evaluate it that way. FOG of 4 is 4 squared. Hey, remember I did 4 squared, that was the g of 4. There it is, plus 3, I still get 19. So regardless of the method that you choose, you should always get the same answer. It doesn't matter which way you go about thinking about it. You should come to the same answer. So here's another one, and if you want to pause the video and try this, I would love to practice finding f of g of x and g of f of x here. And I'll give you a little warning here as you pause the video and try it yourself. Something weird's going to happen, so that's okay. So just be ready for that. So let's see what happens. FOG means take g and plug it in for f. So I'm going to have 2, and then my bucket is x plus 3 over 2. That's the x minus 3. Now, check this out. When I simplify, the 2's go away, and I get x plus 3 minus 3. I got x. That's curious. G of f of x means I'm going to take the f equation and plug it into the bucket or the variable or the x in the g. So that means I have 2x minus 3 plus 3 over 2. Well, g, this gives me 2x over 2, which reduces to x. So that was the weird thing that I warned you about that was going to happen. We got x both times. And let's talk about why that is. What happens? What does this mean when we get x back? Well, you'll notice that these functions are similar. And if we take f of x and we find the inverse, so remember, we haven't talked about inverses yet, but maybe you'll remember from a previous math course that an inverse, really the definition is it exchanges the domain for the range. So in an inverse function, the domain becomes the range and the range becomes the domain. So they're opposites of each other. We also refer to inverse operations in mathematics. So we say, you know, multiplication has an inverse operation of division, or addition and subtraction are inverse operations. And the reason we call them inverses is because they undo each other. And really that's what's happening here. If we find the inverse for f of x, the first thing we need to do, and our first step in finding an inverse, is to switch the domain and the range. So if I write it in y notation, 2x minus 3, my first step is going to be to switch the domain and the range. I'm going to exchange the domain for the range. And then the next step is to solve for y. So I'm going to add 3 over. X plus 3 equals 2y. And then when I divide by 2, I get y equals x plus 3 all over 2. So this is the inverse function. That's another notation that we can use for f of x. So we say it's the inverse of f. And it also happens to be the g equation. And when two functions are inverses of each other and we do the composition with them, they undo each other. Because remember, inverses undo. The other way to think about it too is that by finding the domain, by finding the inverse function, remember you're saying y equals. So previously, when you had y equals and then the equation represents what you're going to get in your range. The inputs are the x's. What the equation gives you are your outputs. What you've just done is you've exchanged those two things. So the inverse equation now becomes the equation for the inputs in the original equation. Might seem kind of confusing to think about it that way, but essentially when we plug it in, we get x back. I think it's easier just to think about them as they're the undo functions for each other. So the result should be x either way. So when two functions are inverses of each other, we get this fun relationship here. We get f of g of x and g of f of x both equaling out to be x. So anytime you need to see or test if two things are inverses, you can use this composition trick. Now, here's a little info about the AP exam, because I know that's something that's important, even though we're still very early on in the course. The AP exam, my favorite part about it is that it takes concepts that we learned in class and it asks you to apply them in new and interesting ways. And so some of the new and interesting ways that they ask you to apply them in might seem kind of weird and uncomfortable for us. But we're going to need to get used to this, and we're going to need to get used to dissecting what it is the AP exam is asking us to apply. Because I promise you throughout this course that I will show you every skill you need, and I will show you as many ways as I can to apply them, but I will give you all the tools you need to be able to solve every problem on the AP exam. It's just a matter of figuring out which skill is it that the AP exam is asking me to apply. So here's one of the interesting ways that the AP exam could ask you to apply this particular concept. They love to use little tables and values and things like this. So here's a table of values, and it tells you that two functions are continuous. And that's going to be an important piece of information moving on. The AP exam will always give you weird information, and you might think, why are you telling me that it's continuous? Well, they're giving you information because it's information you need to know. And if they didn't outright say it, then you can't apply some of the concepts that we're going to be learning, especially later on. So when it gives you information, you almost always are going to need that information. Occasionally it's extra and you don't need it, but here they do need to be continuous so that we can find inverses. So here we go. We have specific values provided in the table below. Use the information to find the composite functions. Oh, and I guess here it actually would not matter too much because, you know, we don't need to do anything with inverses, fortunately. But let's see what's going on here. FOG of 0. So remember, this means I need to find f of g of 0. So I'm going to go to the table and I'm going to find g of 0. So G, remember 0 is the input, G of 0 is going to be 1. So this is asking me to find f of 1. So now I need to go back to the table and I need to look in the f column. F of 1 is 3. So this is how I'm going to approach these problems. And I need to be able to read the table, and it's really easy to pick the wrong value. So take your time with it. And if you want to pause the video and try these other three, you go right ahead. Let's try f of g of 3. So f of g of 3, well, g of 3 is 0, so I need to find f of 0. F of 0 is negative 4. G of f of 1, I need to find f of 1. So f of 1 is 3, so I need to find g of 3. G of 3 is 0. And last but not least, g of 0, well, that's asking me to find, let's see, g of 0 is 1, so now I need to find g of 1. So g of 1, my final answer is negative 4. So you have all these nested values, and so it's easy to get confused, and it's easy to lose your place in the table and kind of forget where you're going. So take it slow, and don't think too hard, because you might overanalyze. But this is how you would approach these problems. Now I have one more for you, and this is going to be kind of a bonus question. G of f inverse of 3. Well, let's think about this. Remember I said earlier that an inverse function exchanges the domain and the range. So if f inverse of 3 is happening, then what this actually tells me is that when I plug in a value into my original f equation, I got 3 as my output. Because remember, domain and range, the output and the input are exchanged. So what this is saying is that there was some f of x that was equal to 3. What was the x? The x is the output. It's the input of the original and the output of the inverse. So f of what makes 3? So if I look at my table, f of what makes 3? I'm going to look right here. F of 1 makes 3. So f inverse of 3 is equal to 1. The domain and the range are exchanged. So this is actually asking me to find g of 1. So g of 1 is negative 4. So there's your little bonus question, and that's a tricky one, and I wouldn't put it past the AP exam to include something along those lines. But for now, I want to encourage you guys to keep going. You can do this, and I'm here for you. You've got this.